for you. So I didn't have the answers for the 12-volt Zener. So then I got, oh crap.
How about we do them both?
Yeah. I forgot all about not doing a key for my. So that'll be all right. We'll see how good I can wing it on my own here. So see if I can remember everything. All right. So I do want to change just make sure you change the RS on your sheet to 100 ohms. It's going to be a 12-volt Zener. And then we're going to complete the table on part 1 there. So we're going to first analyze this circuit. We're going to analyze it with a our source voltage is going to be 20 volts. We have our polarity. So again, now we know that, so if we do our current paths and polarities, we know that, ideally that, my current is going to be coming down out of here, coming through here, it's going to hit this first current node. If the diodes go, either go diode or go Zener, we know that the current is going to go up this way, and up through here. And these two currents are going to combine, and all my current is going to go through my current limiting resistor. So I got all my current's going to come out, it's going to come through, some of it's going to split, some of it's going to go through my Zener, some of it's going to go through my load. Those two currents are going to combine back together and go through our current limiting resistor, which is going to be my IT now, and then back into my source. So that's important when we're looking at these Zener regulators. Zener uses them as a regulator because, again, these are current-driven devices and stuff. So we're always kind of looking at what is our current going through all our components. All right, so once we get that point, then we know that we have 20 volts for our source. We have a 12-volt Zener. What's going to be my voltage across my load then? If it's in a normal, assuming that everything's in a working condition, what's going to be the voltage across my
12 volts.
12 volts. Okay. So if I have 12 volts dropping across my Zener and 12 volts dropping across my load, how much voltage is going to be dropping across my current limiter resistor?
8 volts.
8 volts. Okay? So I'm going to have 8 volts going through here. If I have 8 volts going through there and I have a current limiting resistor of 100 ohms, what's going to be my current going through RS?
80 milliamps.
80 milliamps. Let's see, did I do the... That's one number I got to calculate out yet, so I got... I'll tell you what the load is here. So my load is going to be a 680 ohm resistor. All right, so I got 80 milliamps of current going through my current limiting resistor, which is also my total current. Then how much current do I have going across my load?
40. Yeah, 17.64 milliamps. So how much current do I have? How much current do I have going through my Zener then? A lot.
Instead of a lot.
The remainder of
Those are LabVIEW answers. We're engineers in here.
We are?
The slackers in that room. Yeah, those are answers that we...
Where's that welding class right now?
Got you. You were all good students up until you had Tom for our teacher, and all of a sudden you all turned into slackers. I tell ya.
What's that Appalachia Fest? You know?
God, jeez.
It's that breakdown of the Zener once you're in it kind of stage.
Yeah.
Once you're
All right. So how much current do I have going through my Zener then? And how do I calculate it out?
62.36.
All right. So the current of my Zener is equal to 62.36 milliamps. How did you figure that out?
I subtract.
Yes. Yeah. So we knew that all my current was coming out of my power supply. Some of it went this way, and 17.64 milliamps, which we could calculate out, we knew went this way. Then those two currents had to combine, and then my total current again. So these two currents here, we knew they had to equal up to our 80 milliamps. So we just took 80 milliamps, subtracted 17.64 milliamps from it, and the remainder amount of current was going through our Zener. So what's my resistance of my Zener?
Whatever.
$192.4 ohms.
Yeah, so it should be equal to 192.4 ohms. That's the resistance of my my Zener there. Just taking your voltage of your Zener, divided by your current of your Zener, and that'll give you what the current of your Zener is, or your resistance of your Zener is. Then if I know my power, if I know my voltage and I know my current, then what's my power going across my Zener? Yeah, so 748.2
32. Or 3.
3? What, 3? 748.3 milliwatts. So am I within range of my specifications of a 1-watt Zener? Yeah, I'm still within range, but I'm getting pretty close to. Yeah, getting pretty close to on the edge of that tolerance there. All right. All right, any questions on that first one then? Okay, I'm gonna print out multiple sheets for you. I know that. They're talking about doing that, getting I think Mindy had the idea of doing more of the duplicating the schematics on your worksheet so that you can. It's kind of tough. Either that or you have to just draw them out. But on my next lectures, I'll make sure I give you enough circuits so you can redo them. That was a good idea. I never even thought about doing that. All right, so our next one is going to be 16 volts. Still my 12-volt Zener. My load is still going to be my 680 ohms. RS is still going to be 100 ohms. Okay, so what's going to be my voltage across my RS? My current limiting resistor, what's going to be my voltage going across RS? So we know we got a
4 volts.
Yeah, so we know that we had 12 volts here, 12 12 of that volts is going to drop across my Zener there, and so the remainder is going to drop across here by 4 volts. Okay, then what's going to be my total current, or my current of RS? $40 milliamps. Then what's going to be the current of my load then? What's my voltage of my load going to be?
12 volts.
12 volts. So what's my current going to be going through my load?
17.64 milliamps.
17.64 milliamps. Doesn't change. It's still going to be, even though my voltage across my source drops, my voltage across my load is still going to be at that 12 volts, and so I'm going to still get my 17.64 milliamps across my load. Then what's my current now going to my Zener?
22.36 milliamps.
Yeah, 22.36 milliamps. Okay, what's my resistance of my Zener now?
A lot less.
A lot less?
No, a lot more.
Oh, a lot more?
In between less and more.
Somewhere between less and more? Either or.
536.6 or 0.7.
Yeah, 536.7 ohms. Yeah, so a lot more, not a lot less.
Right.
Got less current going through there, so we got more resistance. Yeah. And then what's my power of my diode now? If I have less current going through there, what do you expect my power to do across it? Get less. So what is my actual power then going across my Zener?
268.32.
What did you get?
I had 268.32, but
268.13 milliwatts. Okay. So yeah, so you can see that, as I increase my source voltage, I have to be careful of that power of that regulator as I start to increase the voltage across that my source voltage. So that's because that's always going to take up the remainder amount of current. Whatever the load doesn't take, the Zener is going to take the remainder amount. All right. So far, pretty straightforward. All right, so our next one. This one here, we're gonna kind of do it as a little longer method here. So this one's going to be our 5.5 volts. It's going to be our source. This one here, we know that we have our 12 volt Zener here. We have 5.5 volts for our source. So this time we're going to go ahead and analyze it the long way, using our soft voltages and stuff like that. I didn't want to do it on all of them because it's a little bit tedious, but this one here we're going to do our soft voltages. So we always want to, when we're analyzing our Zeners, we're going to circle our active component, put in our polarities in there, bring over our soft voltages. So I got 680 ohms resistor here, 100 ohm there. Okay, so we're going to treat that diode as an open. And then we're going to bring our soft voltages over. So what would be my soft voltages on my cathode side of my Zener? What would be my soft voltage?
5.7 volts. Plus or minus 0.
Positive 5.5.
So we treat
It
this
isn't open yet.
treat the Zener as an open, right? And what would I measure for my voltage at this point then?
5.5.
Okay. So by okay, so let me redraw up our equivalent circuit here. So we're going to treat that. So we're going to treat that Zener as an open, so it's not even part of our circuit. Here's RS of 100 ohms, and I have my RL of 680 ohms. And if I'm gonna, so actually I'm just basically I'm doing the same thing, right? I'm measuring the voltage across my load, right? It's the same thing as what my soft voltage would be here. So what I've been essentially doing then is I'm just going across my load. What would I measure on this circuit across my load? What would I measure for voltage at this point here?
4.794 volts.
4 point, was it?
4.795.
795 volts. Okay? Because when I treat this diode as an open, now I just have a series circuit. What's another name for a series circuit? Voltage divider. Okay? So we have to treat it as a voltage divider. So at this point here, then I would have my soft voltage of a positive 4.795 volts. Okay? So sometimes it's nice to go ahead and draw in, draw your equivalent circuit without that Zener in there. And if we put the Zener back in, we know that's exactly what I would get for a voltage at that point. So I'd be at a positive 4.795 volts on the cathode side, and on my anode side I'd be what for a voltage for a soft voltage?
0.
Yeah, plus or minus 0.
How do you get the 4.795?
It's our equivalent circuit here. So remove that diode, right? So the only thing I have is RS and RL, right? So I have a voltage divider, right? So if I'm measuring here, basically I'm measuring across whatever I've measured for voltage across RL. Okay? So I just used my voltage divider formula and divided up my voltage up there. Alright. So now we have to determine, so I'm more positive on my cathode side than I am on my anode side. And is that going to be a go diode, go Zener, or no go?
Go diode.
No go. Right? Because I'm more positive on my anode, right?
Right, yeah.
Than my anode. And so then I got to look at it. Could it be a Zener? Well, I got to make sure I have a voltage potential of greater than 12 volts. And do I have a voltage potential greater than 12 volts? No. So then I know at that point it's either a diode or a Zener. It's a no-go. So now I'm back to my equivalent circuit at this point. That diode is just going to act like it's out of the circuit there. Okay? So now what is so what's my voltage across RS then?
.705.
0.705 or
It's 705.1 millivolts.
yeah, better. 705.1 millivolts is what's going across RF. So then what's my current going through my RF then? Yeah. 7.051 milliamps. what's going to be the current load across my load? So to calculate out my load, I need to get my voltage. What's my voltage across my load?
The 4.795.
Right. So the voltage across my load is going to be my 4.795 volts. Now, because I know my voltage, I know my resistance, and I can calculate out my current. What would be my current going through my load then?
Series circuit.
Yeah, it's a series circuit. So it's going to be how many amps? Yeah, 7.051 milliamps. Yep. Whatever's going through RS, going across my load. This kind of stuff that I like to hear is that a lot of times we use our calculator way too quick. So how much current is going through my Zener then?
None.
None. What's my resistance of my Zener? Very high or very low?
Isn't it infinite?
Infinite. Good. And then what's my power being dissipated by the Zener?
0.
0. There's no current, and I can't have any power. All right. Yeah. So those first two times there, just so you can understand how that Zener works, we did it without analyzing, doing our soft voltages. But you can see if you don't use your soft voltages, then you can get yourself trapped. You can kind of make way too many assumptions. You can assume that, we would assume that we might have gotten 12 volts going across here, 12 volts across our Zener and stuff, and you did all your calculations and then realized that we didn't even have enough voltage even to supply the Zener to maintain regulation. So at that point, then this thing is out of regulation. It's not regulating the circuit. It's not even part of the circuit. So there's no regulation. Even though I have the Zener in there, it's not regulating the circuit. All right. All right, so on your own, use 3 volts this time and tell me what you get for your answers. So I'll let you do this one.